So how do scientists predict something as complex as fire? Well, today we're looking at Optima++.
It's a huge challenge, It involves massive data sets and these super complex chemical models.
So here's our game plan. We'll look at the problem and how this software tackles it.
Right now, researchers are juggling tons of different tools for their data, models, and simulations. But what if one tool could handle the whole shebang? That's exactly the idea behind Optima++.
And it's not some old software. It's an active, open-source project from a lab in Budapest.
Basically, it's a central hub that brings all those scattered research tasks under one single roof. Okay, so let's start with the first big headache, dealing with messy, raw experimental data.
Optima++ takes that messy text and turns it into clean, structured XML that a computer actually understands.
And get this, it's all done with one simple command, txt to XML. Imagine the time saved.
It's that easy. You just point to your file, run the command, and boom, structured output. So, with your data all clean, the focus shifts to the chemical model, also called a mechanism.
And instead of slow manual editing, you use the MSRCHMOD block for fast, scriptable changes.
For example, check this out. One command can strip out everything but these specific elements, instantly.
And why does that matter? A smaller model means way faster simulations. It's a huge deal.
All right, so we've got clean data and a tight model. Now it's time to run some simulations.
Now, Optima++ doesn't replace these big-time solvers. It just tells them what to do, like a conductor.
This modify then test workflow is where things get really cool. It's super seamless.
So first in the mechmod block, we just give our new, smaller mechanism a simple name. Then, over in the mech test block, you just call that same name to run your simulation.
And that's the whole workflow. Standardize data, modify your model, and run a test, all in one script.
So really, what we're looking at is a toolkit that just streamlines everything from start to finish.
This all means repeatable science, way less time wasted, fewer errors, and research that's more accessible.
By taking care of all the tedious stuff, it lets scientists focus on the real goal, discovery.